December, a festive time of year, and as an amateur astronomer, I love December evenings. The skies are crisp, there's so much to see. Of course, around here you've got to be bundled up because of the cold, but there's some great observing to be had. In this episode, we'll explore the planets and let you know how to see them. We'll go over the solstice, the potential for a great meteor shower, and explore some of the best deep sky objects that are visible on December evenings. If you're watching on YouTube, please like and smash that subscribe button. And if you're listening on audio, please leave us a review on your podcast platform. We really appreciate that. We really love getting questions, suggestions, comments, and reviews from you. And you can do that. You can leave comments in the comments down below, or you can always email us at astroguypodcast@gmail.com, or leave us a voicemail at 973-404-0380. We're going to be holding a contest soon once we get to 1,000 subscribers on YouTube. Tell your friends to check us out. If you'd like to help support the Astro Guy podcast and YouTube channel, you can buy us a cup of coffee. Any money collected is used to maintain and update the equipment that we use to create and publish the show. The link is in the show notes. Thank you. Okay, let's get to what's up. Welcome to the Astro Guy podcast. I'm not an expert. I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem. Seize the night. Welcome to the Astro Guy podcast. I'm your host, Wayne Zool. If you have a good eastern horizon, you might be able to catch Mercury around 6:30 a.m. on the morning of the 31st. It will be about 5 degrees above the horizon at that time. The first week of January will be a bit better to catch the innermost planet. To spot it, try using binoculars to pick it out of the twilight glow. It's shining at magnitude minus 0.6, and in a telescope, it appears as a thin crescent about 8 arc seconds across. Now, Venus is still ruling the pre-dawn skies this month. On the 1st, Venus rises at 3:21 a.m., and it shines brilliantly at magnitude minus 4.19 while showing a gibbous phase of 68% and spanning 17 arc seconds in diameter. On the 1st, you can spot magnitude 1.3 Spica, 4.5 degrees directly to the right of Venus. This will be a pretty pairing. By the end of December, Venus rises at 4:24 a.m. and will have dimmed slightly to magnitude minus 4.04, and it will show a 77% illuminated phase, but will have shrunk to about 14 arc seconds. You'll still have at least an hour of Venus viewing if your horizon allows. On the morning of December 9th, the 26-day-old moon will be less than 4 degrees southwest of Venus. The moon will display a 13% illuminated crescent. This should be a wonderful sight. Mars is lost in the glow of the sun all month long. Nestled in an orbit beyond Mars, but closer than Jupiter, is the main asteroid belt. On December 21st, the asteroid Vesta will be at opposition, rising when the sun sets, and it will be at its brightest, about magnitude 6.3. Bright enough to be seen from the darkest of skies without any optical aid, but easily visible from modestly light-polluted areas with just binoculars. While this potato-shaped asteroid spans about 163 miles in diameter, to us it appears as just a pinpoint, even with a telescope, as it's small and far away. But just getting a glimpse of this asteroid is worth it, as it's one of the most studied of all the asteroids, and it's been proven to be the parent body of the HED, or Howardite, Eucrite, and Diogenite meteorites. Hundreds of these meteorites have been recovered on Earth, and have given us a chance to study up close the surface of Vesta. On the 21st, Vesta will be 3/4 of a degree east and 1/4 of a degree north of the magnitude 4.5 star 54 Orionis. If you enjoy observing the gas giants, then December evenings are going to be a lot of fun for you. Jupiter is ruling the evening skies this December. As the month begins, Jupiter rises at 2:49 in the afternoon and transits the meridian, placing it at its highest point in the sky, nearly 62 degrees above the southern horizon. Jupiter sets at 4:21 in the morning on the 1st. It glows brilliantly at magnitude -2.8 and spans more than 47 arc seconds in diameter. By the end of the month, Jupiter rises at 12:46 in the afternoon and transits at 7:30 in the evening. It will have dimmed slightly to magnitude -2.4 and will appear to have shrunk to about 44 arc seconds in diameter. On December 21st, the 10-day-old waxing gibbous moon will be about 6.5 degrees west of Jupiter. This will be a stunning sight in binoculars or just with the naked eye. In binoculars, Jupiter will appear as a bloated star, and you should be able to make out the 4 Galilean moons. In a telescope, you'll be able to make out details on the planet, such as the equatorial bands, and when it's facing us, the Great Red Spot. Apps like Mobile Observatory can show you when the red spot will be visible where you are. Jupiter will be in the sky most of the night on December evenings, and it's always worth a look. Since Jupiter rotates on its axis about once every 10 hours and has a very dynamic atmosphere, it always looks different, so definitely make sure to check it out. As darkness falls on December 1st, Saturn is at its highest, nearly due south. It's glowing at magnitude 0.87, and with the rings, the planet spans about 39 arc seconds across. By the end of the month, Saturn will be about 30 degrees above the southwestern horizon at sunset, and will have dimmed to magnitude 0.96. It will appear to have shrunk slightly, spanning only about 37 arc seconds. So get your Saturn views in now, as it will soon be lost in the twilight glow until it reemerges in the morning skies next year. In binoculars, you can just make out Saturn's rings, while in a telescope, the planet and its rings are one of the most amazing sights that you'll ever see. On December 17th, the moon will be 3 degrees due south of Saturn, making for a beautiful pairing in the southern sky. Uranus is well placed on December evenings, a little east of Jupiter. On the 1st, the 7th planet in our solar system transits the meridian at 10:26 p.m. and glows at magnitude 5.67, while spanning about 3 arc seconds in diameter. By the end of the month, it transits about 2 hours earlier. Its magnitude and apparent size won't have noticeably changed, however. You can spot Uranus in binoculars. In a telescope at high magnification, you can make out the disk of the planet. Uranus spends all month long in Aries, and is easy to spot about halfway between Jupiter and the Pleiades. On the 22nd, the moon will appear between Jupiter and Uranus. Neptune is in the southeastern skies as December begins. The 8th planet in our solar system glows dimly at magnitude 7.75 and can only be glimpsed with binoculars or a telescope. At higher power, you can detect its blue-green disk, which spans a little more than 2 arc seconds across. By month's end, Neptune will be low in the southwest as darkness falls, so get your views in now before it gets lost in the glow of the sun early next year. On the night of December 13th into the morning of the 14th, we see the peak of the annual Geminid meteor shower. The Geminids and the Quadrantids are the only major meteor showers whose parent body is not a comet. The parent body of the Geminids is the asteroid 3200 Phaethon. This year, the moon will not interfere with the meteors, and the radiant will be more than 60 degrees above the eastern horizon by midnight. The ZHR, or zenithal hourly rate, is 120, but you can expect to see less than that. If you're under very dark skies, you can expect to see 60 or more meteors per hour. The best times to spot the Geminids will be between midnight and 3 a.m. Just make sure you dress warmly, in layers, and bring a chair or a blanket to sit on. The winter solstice occurs on December 21st at 10:27 p.m. Eastern. This is when the sun reaches its furthest point south, and it is the shortest day of the year for those in the northern hemisphere. Interestingly, The latest sunrise occurs a couple of weeks earlier on the 10th, while the earliest sunset happens on the 30th. Okay, let's take a look at some of the best deep sky objects that can be seen on December evenings. As darkness falls on December evenings, our first object will be high in the northern sky. Let's take a look at the open cluster M52, which is also known as the Salt and Pepper Cluster or the Scorpion Cluster. Listed at magnitude 6.9 and spanning about 10 arc minutes across, this gorgeous open cluster is located about 4,600 light-years away from us. The cluster itself is less than 10 light-years wide and is comprised of about 200 stars. In binoculars, the cluster appears as a rounded, hazy patch, while a few brighter member stars can be resolved. In a telescope, this colorful cluster really shines, as it displays red, blue, white, and yellow member stars, and should provide you with hours of enjoyment at the eyepiece as you take it in. Locating M52 is a breeze. Start at Shadar, known as Alpha Cassiopeia, and sweep to Cap, or Beta Cassiopeia. Now continue on that line for another 6 degrees, and you'll spot the cluster. After you've had your fill of M52, nudge your scope a half a degree to the southwest, and you'll see a hazy patch of nebulosity. This is Caldwell 11, or Sharpless 162, or NGC 7635. However, it's commonly referred to as the Bubble Nebula. This object can be a bit of a challenge to spot, as you'll need at least a 6-inch scope under pretty dark skies, but it's worth the effort. It is easier to spot using a nebula filter if you have one. The bubble glows dimly at about magnitude 10 and spans 15 by 8 arc minutes in size. The complex of nebulosity is about 10,000 light-years away from us. It was discovered by Sir William Herschel in November of 1787. Check out our Great Astronomer series, where we do an episode about William Herschel. We'll leave a link to it in the show notes. The bubble itself is formed by the stellar wind created by the magnitude 8.7 star SAO 20575, which has a mass about 44 times that of our Sun. While it's a bit of a challenge, it is a fun object to visit, especially due to its proximity in the sky to M52. Another nebula that's a bit south and east of the last pair of targets is the bipolar planetary nebula M76, known as the Little Dumbbell Nebula. It was discovered in 1780 by Pierre McCain. This nebula glows at magnitude 10.1 and spans about 2.5 by 1.5 arc minutes in size. Due to its size, even at magnitude 10.1, it's relatively easy to spot in a 6-inch scope. I've been able to see it with a 70mm refractor under dark skies. M76 is located about 2,500 light-years away from us in the constellation Perseus. Locating it is easy. Start at 2nd magnitude Almach, known as Gamma Andromedae, and sweep north for 8.5 degrees. Now sweep west for 3.5 degrees, and you'll come to a 4th magnitude star. Now sweep another 3/4 of a degree north, and you'll have the little dumbbell right in your eyepiece. Our next object is large and bright, and if you've been following this channel, you know that means that it's really not easy to see, as its light is spread out over a large area. NGC 1499, also cataloged as Sharpless 2-220, is commonly known as the California Nebula, due to the fact that in long exposure images, it sort of looks like the shape of the state of California. Spanning more than 2.5 degrees by 1 degree in size, this emission nebula glows at magnitude 6, and it's located about 1,000 light-years away from us in the constellation Perseus. It was discovered by E. Barnard in 1884. An interesting coincidence is that the California Nebula transits the zenith in central California. This is because the latitude is the same as the declination of the nebula. Now, magnitude 6 is within the range of naked eye visibility, but due to its large size, the California Nebula is tough to spot without any visual aids. I've spotted it twice with the naked eye, once on a fishing trip about 65 miles off the coast of New Jersey, and the other time was in the desert on the California-Arizona border. To me, it appeared as a very faint, hazy glow, but under those pristine skies, it stood out above the background. But it was still a bit of a challenge. It's best observed with binoculars or a telescope at very low power. I've enjoyed it many times with 7x50 binoculars. However, darker skies and using a nebula filter will definitely help you to see it. To locate the California Nebula, start at the fourth magnitude star Menkib, then sweep 1 degree to the northeast, and you'll see the nebula. Our next object is a bit easier to see. Let's explore the first object in Messier's catalog, M1, the Crab Nebula. This is a supernova remnant from a star that experienced a cataclysmic explosion, or a supernova, in the year 1054 AD. It was witnessed by astronomers nearly 1,000 years ago. It got so bright at the time that it was visible during the day for a few months. Since then, it has faded to its current magnitude of 8.4. It is one of the most studied objects by astronomers, and its progenitor star is now a pulsar that's been extensively studied since the 1960s. The crab spans about 7x5 arc minutes in size, and visually, it appears oval in shape. It's estimated to be about 6,500 light-years away, which would make it about 13 light-years long by about 2 light-years wide. In a telescope, the crab looks like an oval glow. Using larger apertures, you can detect the filaments that run throughout the nebula. I've been able to observe the filaments with an 8-inch scope from dark skies. Finding the crab is pretty easy. Start at magnitude 2.9 Zeta Tauri, known as Tinguan, and sweep 1 degree north and 3/4 of a degree west, and you'll spot the crab. Our next deep sky object is likely one of the easiest to find, and if it's not already, it surely will become one of your favorite winter deep sky objects to view. I'm referring to the Great Nebula in Orion, which is cataloged as M42. This complex of emission nebula is one of the easiest and most observed DSOs in the entire sky. Located at a distance of about 1,340 light-years from us, the complex itself is more than 20 light-years wide. It's bright at magnitude 4 and spans an area of sky about 1 by 1 degrees. M42 is the closest region of major star formation near us. It has been extensively studied by astronomers for centuries. In binoculars, it is a stunning object. While best viewed at low power in a telescope, the Orion Nebula shows lots of variations in brightness. You'll see areas of bright and dark nebula all through the field. When looking at M42, you'll notice a comma-shaped wedge of nebulosity near the trapezium, which is a grouping of 4 stars located in the brightest part of the nebula. That comma-shaped wedge is M43, which is part of the Orion complex. Now, if you sweep about half a degree north of M43, this will bring you to a fainter patch of nebulosity known as NGC 1977, or the Running Man Nebula. 3 objects for the price of 1. To locate M42, start at Orion's belt. The leftmost star is Alnitak. About 3 degrees south of Alnitak are 3 stars that form the Sword of Orion. M42 is the middle star in the sword. Easy peasy. Our next object is also a 2-for-1. For now, we'll move to the constellation Gemini and examine the stunning open cluster M35. Made up of around 418 stars, this cluster glows at magnitude 5.2 and spans 28 arc minutes in size, making it appear about the same size as the full moon. M35 is located 2,970 light-years away from us, and the cluster itself has a radius of 11 light-years. From a dark sky sight, you can pick it out without any visual aid as a faint, hazy patch of light. You can spot it easily in binoculars as a fuzzy patch, about the size of the moon. In a telescope, you'll be able to resolve dozens of member stars in the cluster. There are a few brighter reddish stars that stand out from the rest. Do you see them? Located less than half a degree southwest of M35 lies the open cluster NGC 2158. Listed at magnitude 8.6, this cluster appears dimmer and smaller than its neighbor. NGC 2158 spans about 4 arc minutes in size. And even though it's about the same size as M35, NGC 2158 is about 4 times further away, making it appear smaller and fainter than M35. To locate M35, start at magnitude 3.3 Propus in Gemini and sweep 2 degrees north and 1.5 degrees west, and you'll spot M35. The last object on this month's tour is a fun object that I always check out on winter evenings. I'm referring to the open cluster NGC 2169, which is known as the 37 cluster, as its members form the number 37. The cluster is located near the border of Orion and Gemini in an area devoid of bright stars. There are 2 fourth magnitude stars near the cluster, which helps in locating it, but we'll get to that in a moment. Made up of about 30 stars, NGC 2169 glows at magnitude 5.9 and spans about 6 arc minutes in size. It's located about 3,600 light years away from us. In binoculars, it appears as a small patch of light. Using 15 by 70 binoculars from a dark sky site, I can see the 37 pattern, but it definitely looks better in a telescope. Because it's only 6 arc minutes in size, you can crank up the magnification a bit to explore this cluster. It's definitely a lot of fun to observe, and it's pretty easy to locate. To find it, start at Betelgeuse, the bright red star in Orion. Now sweep northeast about 3 degrees until you come to 4.3 magnitude Mu Orionis. Now sweep north 2 degrees until you come to a 6th magnitude star. Now sweep northwest about 3 degrees and you'll come to a 4th magnitude star. You should see another 4th magnitude star 1 degree to the northeast as well. NGC 2169 is located 3/4 of a degree south of that star. I do hope that you'll go after these objects and that they become favorites of yours as well. Well, that's all for this month. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy podcast group on Facebook. You'll find other members, videos, blogs, and lots of other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please subscribe. Please consider leaving us a review on your podcast platform. It helps us to get new listeners. Thank you again for listening, and may your skies be clear. As always, Carpe Noctem, seize the night. I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.